I'm calling this chapter 2. This is really like unit number 2. We're not really following a certain textbook, so we're going to kind of just call this chapter 2, even though it's not really a chapter, right? But we're going to talk about measurements and how we take correct measurements, how we read measurement things correctly, and we're also going to talk about the metric system and using units correctly, okay? When I say the word units, do you know what that means? When I say the word units,
like units in volume.
Kind of. Okay, so where do units usually go? Like with a number, do they go before the number or after the number?
After.
They go after. Good. And give me an example of some different units. Celsius is one. Good. Inches, grams, pounds, right? Anything that you attach to a number to prove that it's a measurement is considered a unit, right? If we're telling how long something is, how tall, how heavy, how fast, right? Miles per hour is a unit. There's all these sorts of types of units that tell us what type of measurement this is, what type of number this is. That's what units are. And so in this chapter, we're going to deal with converting between different types of units. We're going to look at measuring correctly with units, things like that. So we're going to introduce the metric system. Okay, the metric system. Some of you said you're not super familiar with the metric system, but the metric system is really called the international system of units. Every other country, almost, okay, mostly every other country in the world uses the metric system. The United States does not. Okay, the United States measures with the United States system. And so where we measure our length, what do we measure length in? What are some things that the United States measures length in? Inches, and what else? Feet, miles, yards, right? We have all of these different versions of measurements, but with the metric system, they use the meter, right? They use a meter, and then they use, for smaller measurements, they use part of a meter called a centimeter or a millimeter, or for bigger than a meter, they use a kilometer, right? They have all of these things that are based on that unit itself. Right? So there's a different system that they use. The reason that we go about using the metric system is that, and the reason we learn the metric system in our science classes is because science uses the metric system so that we have a universal way to report our findings. Okay? If everyone is to understand what your measurements mean, you have to agree on the units, right? If I'm going to report my findings in a scientific journal, or if I'm going to report my findings to other scientists and I'm using Fahrenheit and they don't know what Fahrenheit is, right? It's hard for them to figure out, well, what did my experiment really do? Right? Or if I'm using inches and they usually use centimeters, right? It's hard for people to get a grasp around what that really means. And so in our science classes, we practice the metric system. Okay? So the metric system has been called the international system of units. That's been what's kind of the standard for all scientific work, even in the United States, right? For science, we use the metric system. They also are called SI units for System International. That's what SI stands for, System International, or we call it the metric system, right? So there's a couple of different names for it, but the SI system or the metric system, it all means the same thing. Right? It means that we're dealing with these different sets of units. Okay? Why do we use units and why are units important? Okay? When I say carrying the units throughout the whole problem, that means if my measurement starts out as 4 centimeters, I've got to write centimeters behind that number the whole time, right? So I know what my number means. Okay, when we say we use units, we're telling what does that number represent? Does it represent 4 centimeters or does it represent 4 miles or 4 whatever, right? If we just have a number without a unit, it doesn't tell us anything about the number. So we use those units to show what was being measured. Was it length? Was it time? Was it mass? What were we measuring there, right? That's what the unit tells us. Without units, our measurements, they don't make any sense. They're just numbers. So we've got to include units with all of these things. So do we feel comfortable with when I say units, what that means? inches, centimeters, grams, pounds, whatever it might be. We're going to use a mixture of US and metric to start, and then we'll kind of get all the way to the metric system. Okay, so our goal when we turn in answers is to have no plain numbers. Our goal is to always make sure we have a unit with our number, right? If it asks me, how long did it take for me to do something? What do you think an appropriate unit would be for my answer? If it asks me, how long did it take to do this? What do you think an appropriate unit might be?
2 hours.
Yeah, hours might be an appropriate unit. What else? Seconds might be an appropriate unit. Minutes could be an appropriate unit. It might even be days, right? But if the question was, how long did it take? Would meters be an acceptable unit for that? No, right? So we've got to think about what is the correct unit. So not only is our goal to have units on each number, but it's got to be the correct unit, okay? Okay, the metric system or the SI system, those two things mean the same thing, right? Metric and SI mean the same thing. They have 7 what are called base units. And when we say base units, that means these are the units that these different quantities are usually measured in. So there's 7 of them. Length is usually measured in meter, and it's given the abbreviation of just an M. Okay, so go ahead and fill out this table in your notes so you have all of those 7 base units, and then we're going to kind of talk through each one and what they mean. So when we call these base units, this means if I were to go measure something in time, if I were going to go measure time, the most commonly used unit would be seconds. Okay, when we say base unit, it's like the most common unit that's used. So meters is for length, kilogram is for mass, time is seconds, temperature is something called Kelvin. Have you heard of Kelvin before? Okay, Kelvin is basically the metric system use of temperature. So it's not actually called degree Kelvin, it's just called Kelvin. That's an interesting one. And it has a direct relationship with Celsius. Okay, so we'll look at that a little bit more. And then moles are something we'll use a lot with chemistry. Moles is it's a quantity of atoms. It's a big number of atoms. So 1 mole is equal to 6.022 times 10 to the 23rd atoms of any molecule. That would be considered 1 mole. So it's a big substance. And then these two we will not really ever get to. Electric currents are measured in amperes or amps. That's probably a term you've heard before, is amps, right? That's how we measure electric current. And then light is measured in something called candelas. Candelas is something you'll see sometimes you'll see it even on lighting boxes. If this is however many candelas, it's different than watts. So usually your light bulbs are sold by wattage, right? This is a 60 watt light bulb. But sometimes you'll see candelas on there. It just kind of talks about the brightness of that light. So those 7 base units, we'll need to make sure we're familiar with those and their abbreviation. Okay? So
What's the difference between watts and candelas?
watts have more to do with the electric current part of it instead of the light intensity of it. All right, so why do we use the metric system, or why do we use the SI system? They make measuring and calculating much easier. The metric system is based on tens. Everything is based on tens. Okay, measurements are expressed as decimals, not as fractions. So with our US system, and if I'm thinking between inches and feet, how many inches are in 1 foot? 12. Does a fraction of a foot make a really nice decimal for us? 1/12 is not a very nice decimal, right? 7/12 is not a very nice decimal. Okay, so with the metric system, everything is on the basis of tens. There are 10 millimeters in a centimeter. There are 10 centimeters in a decimeter. 10 decimeters in a meter, right? They all move by tens. So they give us nice, like easy decimals to work with rather than clunky fractions, right? With the US system, there's not a consistent base for our conversions, right? There's 12 inches in a foot. There's 3 feet in a yard, right? There's 1,500 or so yards in a mile, right? Nothing is really consistent with the US measurement system. So with the metric system, it's much more It's much more consistent. It's easy to change the metric system from one unit to another since everything's based on tens. And another reason we use the metric system is because it's universal. So almost every other country in the world uses the metric system except us. Right? Right, Victoria? Victoria's really good at the metric system. Okay? Because that's how she was taught measurements, right? So it'll be easy for her. Okay? Now we're going to look at all of these prefixes, okay? Tell me first, what is a prefix? Does it go at the beginning of the word or the end of the word? The prefixes go at the beginning of the word, okay? Prefixes can be placed in front of the base units. These prefixes are used to represent quantities that are larger or smaller than the base units. These prefixes are going to be memorized, right? We're going to eventually memorize these. We're going to start out with giving you these prefixes, but these should be something that we become really familiar with that we'll memorize, okay? So here are the prefixes that go with the metric system. Giga, mega, kilo, hecto, deca, deci, centi, milli, micro, and nano. Do those ring a bell to you or not so much? A little bit? Okay, so that means you've heard them before but you weren't quite sure they were called the metric system. Okay, so these prefixes go before any type of unit. They can go before meters. They can go before grams, liters. They can go before seconds, right? Candelas. Any of these can have those prefixes with them. Okay? You'll see over here, there's a clear definition between where the prefixes make bigger numbers and smaller numbers. So here is the base unit. That means 1 meter might sit right there. Okay? And that means a decimeter, right? Decimeter is how I would write that, is 1/10 of a meter, right? Do you see that where that comes from? 0.1 of a meter. A centimeter is 100th of 1 meter. Does that make sense how the table is set up? Okay, the prefixes that are below this blank space or the base, those are units that represent quantities smaller than the base. And above it means those are quantities that are bigger than the base. So a kilometer or a kilometer is equal to 1,000 meters, right? 1 kilometer is equal to 1,000 meters. Do we see how that works out? Okay. So let's go ahead and see, let's answer some questions here using meters for these. Okay. Those prefixes can apply to any of the units, meters or grams or liters or whatever it might be, right? Those prefixes apply across the board, not just to meters. But we're going to practice here with meters. So looking at your table and helping us decipher this, how many meters are in 1 gigameter? How many meters are in 1 gigameter?
1 million.
Okay, how many?
1 million.
Look back at our table here.
Maybe 100,000.
This is 1 million. I think it's 100 million. Or a billion, I mean, not 100 million. A billion. Okay, because how many zeros are after that? There would be 1,000. There would be 1 million. There would be 1 billion. Okay? So a gigameter is equal to 1 billion meters. Okay? Now, capital M, you'll notice the difference between capital M and little m down here. They mean two different things, right? Big M stands for megameter, and little m stands for millimeter. We need to understand the difference between those two things. So a megameter is how many?
1 million.
1 million meters. Okay? A kilometer or a kilometer is how many? 1,000, right? Kilo is a really, really common prefix with the little K right here. And kilo means 1,000. Okay, that's one that you'll start to memorize a lot sooner. Okay, these two right here, we don't use a whole lot, if I'm being honest. Hecto and deca, we don't use those very often. Okay, but how many are there? How many a hectometer is how many meters? 100. And then a decameter is 10 meters. Okay? Now you see how the question changes a little bit. It says, how many of these are in 1 meter? So now we've flipped to being smaller than 1 meter in quantity. So a decimeter, how many decimeters are in 1 meter? Okay, so we're going to flip the question now. Okay, the previous grid told us a decimeter is 0.1 of a meter. But now I'm flipping the question and I'm saying, how many decimeters are in 1 meter?
0.1.
It would be 10, right? Because if a decimeter is 1/10 of a meter, then that means there must be 10 decimeters in a meter. Does that kind of make sense? So we would say 10 decimeters equals 1 meter. Okay, I'd go ahead and write out that whole thing so you can see the switch here. Okay, and this is how many meters are in one of the bigger unit. Okay, maybe even draw a line right there to kind of show us these are the ones larger than and these are the ones smaller than. So how many, if a centimeter now is 1/100th of a meter, how many centimeters are in a meter? 100. 100 centimeters in 1 meter, right? If centi means 100, that's what centi means, right? Think about cents. How many cents are in a dollar? 100, right? So centimeters means there's 100 of those in the base. Millimeter, if millimeter is 1,000th of a meter, there must be 1,000 of those in 1 meter. Okay, do you know what this little symbol means right here? This is a new one. Okay, you kind of write it like a U with a tail on the front. That's called micro. It's a Greek letter. Okay, but you write it there with a little U with a tail on the front. Okay, and it means there's 1,000,000 of them. One more zero. 1,000,000 micrometers is equal to 1 meter. And then nano is like times 10 to the 9th. So we would say 1,000,000,000 nanometers in 1 meter. Okay. What questions do we have about that? What if I were to ask you, how many grams are in 1 kilogram? How many grams are in 1 kilogram? What would you tell me? 1,000, right? You can look at that same chart that we just filled out and apply the same prefix principles to every type of unit. So just because the practice we did was with meters, it means it still applies to grams and liters and seconds and whatever else it is, okay? So if I were to ask you how many liters are in 1 kiloliter, you would tell me 1,000 liters, right? How many centigrams are in 1 gram? What do we think? How many centigrams are in 1 gram? 100, right? There would be 100 centigrams is equal to 1 gram. Does that kind of make sense? when we're talking about units and how they are related to one another, I always like to give the bigger unit the one. And I like to tell how many smaller units are in that one. It's not as easy for me to understand that a centimeter is 0.01 of a meter. You know what I'm saying? That's less easy for me to wrap my brain around. So I like remembering it this way by saying gram here is the bigger unit. So how many of the smaller unit fit into that? Does that kind of make sense? I don't like to use the 0.01 or 0.01. You know, I don't love to use that. I like to think about how many of that small unit can fit into the big unit. That makes sense? Okay. So let's go ahead. Let's do just a few of these. We're not going to go through all of these here. If we're talking about meters, what name and symbol is given to each of the following units of length? Okay, I only want to do a couple of these here. Let's look at B for sure. This is making us look at the partial part of it. So what unit is equal to 1,000th of a meter? 1 millimeter, right? 1 millimeter would be equal to 1,000th of a meter. What unit would be equal to 10 meters? Down here, letter E. Which one? Decameter. And this one is D-A-M, right? Because deca and deci are different. Okay. And then what unit right here would be matched with 1,000 meters? Kilo. Very good. Kilo means 1,000. Good. Okay, that's a really common one that we should probably know, and millimeters is a common one we should know. Last one here that I want you to think about is which unit represents 100th of a meter? Which one means 100? Centi, right? Remember, think about the dollar. There's 100 cents in a dollar, so there's 100 centimeters in that meter. All right, very good. We don't need to fill out all of those on that. You can if you want to, but again, I don't love using the decimals part of that. That won't be how I represent most questions, okay? All right, let's look at it now for volume. Volume is not the length measurement now. Volume is now how much space something takes up. The unit that is kind of most used for volume is called the cubic meter. Okay, cubic meter. But more often than not, we use the liter. Okay, and liter is represented with just a capital L. Okay, a capital L is how we put liter. So if we put a prefix in front of it, it's usually lowercase, and then we'll put liter, which is an L. Okay. There are two smaller volume units that I need you to know are good to be using here. The two units, milliliters and centimeters cubed. These two units right here mean the exact same thing. So 1 milliliter is equal to 1 centimeter cubed. Okay? Cubic units like centimeters cubed and meters cubed, they are found using the area equation for like a cube. Okay, a cubic meter is when I find the area of the cube, it's length times width times height. So if that cube is measured in meters, it would be meters times meters times meters, which is meters cubed. Okay, so 1 liter is equal to 1 meter cubed. No, that's not right. This one right here. 1 milliliter is equal to 1 centimeter cubed. Have you ever heard the term cc? Like, I need 50 cc's of something. You hear it a lot of time in medical. Okay. The reason they say cc's is because that's what cubic centimeter is, cc. That's how it's abbreviated, right? Cubic centimeter is cc. So it's easier for them to say quickly, I need 50 cc's rather than I need 50 milliliters of this thing. It just makes it easier to say. But they mean the same. They mean the same thing. So let's think about this. If I were to ask how many cubic centimeters, how many centimeters cubed are in 1 liter? What do you think you would answer with that? How many cubic centimeters are in 1 liter?
1.
Not 1. Think about it this way. How many milliliters are in 1 liter?
Centimeters squared.
Go back and look at your prefixes for milli, right? How many milliliters are in a liter? 1,000, right? And so if milliliters and cubic centimeters are equal to one another, that must mean that there is 1,000 of those in 1 liter. Okay, those two units mean the same thing. So if there's 1,000 milliliters in a liter, there must also be 1,000 cubic centimeters in that liter as well. Okay? All right, last thing here. We're going to talk about now how we use it with mass. We've talked about length and volume and mass, okay? Mass and weight mean two different things. There's not something, we don't need to know too much about their distinction right now, but mass is the quantity of matter that an object has, and weight is how much Earth's gravity affects that mass. We usually use these terms kind of incorrectly, interchangeably. Okay, we say weight when we really mean mass a lot. Okay. Mass and weight are often confused and are often used interchangeably when we're not supposed to be using them interchangeably. We're going to dive into weight and mass a lot more in later chapters, but essentially mass does not change, but weight does, depending on your location. Okay, so people like say when you go to the moon, you like feel weightless. You know what I'm saying? Because you float there. Do you actually lose mass when you go to the moon? Probably not, right? Maybe depending on your diet on the way up there. But you're not just magically weighing less. You don't magically have less mass by going to the moon. The difference at the moon is that gravity is not as strong, right? The acceleration due to gravity on Earth is 9.8, and the acceleration due to gravity on the moon is 1.7. So it's roughly 5 times less on the moon than it is on the Earth. Okay, or 4, 3, I don't know what that math is out on top of my head, but we're roughly 3 times or 4 times we weigh that much less when we go to the moon, and it has to deal with gravity. So, all right, what's the base unit for mass? What do you think the base unit for mass is? Go back and look at that table we filled out. What's the base unit for mass? It is kilograms. Okay, kilograms is the base unit for mass. Do you notice anything different about this one than we had with our other units? About it being the base? Did you notice how this base unit already has a prefix attached to it? Right? Gram is really fits in that groove of meters and liters on the chart, but the reason we most likely measure in kilograms is because it's the most manageable unit for us. So gram is a really, really small unit, and if we measured everything in grams, our measurements would always come out in the thousands, right? And so by measuring things in kilograms, we're able to have just more realistic type numbers, right? It's much easier to say this object weighs 4.2 kilograms than to say it weighs 4,212 grams, right? That's just a lot more information. So kilograms gives us a more kind of reasonable number with our measurements, okay? But it still works the same way with all the prefixes, okay? All right, let's review these real quick here, and then I'll tell you what your assignment is for today. So if I was going to measure in centigrams, would I be measuring mass or length or time or temperature or candelas, or what would I be measuring? If I was measuring in centigrams, would I be measuring an object's mass, its volume, its length, its temperature? What do you think? We would be measuring mass, because look, here's gram right here, right? Kilogram is the unit for mass, so that means anything that has gram attached to it at the end means it's a mass measurement. Okay, if I were measuring in millimeters, what would I be measuring? Length, very good. If I were measuring in Kelvin, what would I be measuring?
Temperature.
Temperature, good. That one's kind of a new one for us, but Kelvin is temperature. And then if I was measuring in milliseconds, what would I be measuring?
Time.
Time. Very good. All right, very good.